Hey everybody, back with another video, of course, one that, again, I wasn't planning today anyway to do a video, but last night I was troubleshooting. I was trying to use one of my logic comparators, the nicer of the two, to troubleshoot some missile command board. And what was happening is no matter what chip I tested, this light number 2 or line number 2 was lit solid, and always recording that it was wrong, right? And so I was like, okay, well, what the heck does that mean? Why am I having so many chips that are showing number 2 wrong? And I went down a rat hole, etc. But eventually I came to my senses and used the test connector here that I've shown in previous video that I'll link to. Used the test connector, and it was also showing that line number 2 was bad. I'm just catching you up real quick, and then we'll talk about what this video is going to be about. So once I determined that line 2 was bad, you can come to the schematics and see DS2 is line number 2, and I just used my logic probe on U1 C3, and I could tell that line number 8 was not the same as like line number 11 for the other LED functionality. So trace that back, and it ended up being this U7 chip, which is I replaced with the LS386 excuse me, just like I did in my other video, again, which I'll link to. And one of the reasons why I wasn't going to film that, because I was filming the same thing that I had already filmed. But during that whole process, I started to look at some of the existing cards, the reference cards that came with the logic comparator. And what I was noticing, actually this is a bad example, but what I was noticing is some of them had, broken traces that they had soldered and stuff like that, and I didn't really trust. This is during the troubleshooting process. I didn't really trust that the chips were good, that were directly soldered in. Like this one, you can see this is how it was before. It was just a chip directly soldered in, and they weren't necessarily drilling out the holes on the back like you're supposed to, and I basically just didn't trust it. So I started repairing or redoing these reference cards and putting in medium insertion, socket there. So what do you want to call that? Medium insertion force, or just a socket, basically, is what people call it. And so I did that for 2 of these chips, 2 of these reference cards, a 7442 and a 7410. And I had also done some research on KLOV. There's a guy, I'll link to it as well, who basically did some analysis of what are the most common chips that you'll find in arcade boards, and which ones have common data output lines, so you can basically use the same reference card here for multiple chips. And so that's what I figured we'd do, is just actually show you the process of building a couple of these. And obviously, like, we can use one reference card for a 7400, a 7408, a 7432, and a 7486, or LS versions of those, if you use a socket, 14 pin or 16 pin socket, instead of directly soldering them. And then we'd probably also test a few of these as well. So hopefully at the end of the video, test some of these that I'm not sure about, like this one here, a 174, which is a pretty common chip on arcade boards. Not one of the ones I have listed here, but it is pretty common. The 7404 can also be used with the 7405, 7406, 7407. But since this one is already hardwired, I figured we just test, and if it's good, I'll keep it separate. So, all right, so that's what I'm going to pause. I think I got everything caught up. I repaired basically this logic analyzer, just all of a sudden random. And in my previous video, I tested it and it was fine, and then all of a sudden it just started acting up weird. So I had to replace a LS3086 386 on that, and I'll be right back and we'll do a couple reference cards. Alright, hopefully you guys can see this, and it's nice and stable, but anyway, we're going to do a 7400 card real quick. 7400, 7408, 7432. And then if I have this TTL book here. I could actually use one that's a little bit, this is nice actually, it's good, you know, I'm learning a lot reading it. But anyway, a 7400 is 14 pins, and if you can see that, like there we go, and it tells you what the outputs are. So we know the outputs are 3, 6, 8, and 11. 3, 6, 8, and 11 on a 7400. And a 7408 is, let's see here, also 3, 6, 8, and 11, and that's why we can use the same reference card with a socket for those 2 chips, or actually also a 7432. I'm not going to show you all of them, but that gives you the idea. On the reference card itself, there's a top and bottom, and this is the bottom, and what it's telling you to do is to I'll actually show you later, but basically you insert the socket, connect pin 1 over here to ground, and then it'll be pin 7 or whatever to ground, and then this one over here, pin 14 to VCC. I'm going to show this in a second. And then you put the socket on this side, and then you drill out up here. You will drill out. Let's see. This is 1, 2, 3. We're going to drill out number 3, number 6, number 8, and number 12. I guess I don't know. I have to look it back up. I already forgot. So basically, we're going to put in our chip like this with the little notch basically facing down, just like that. So it's going to look just like that, and then when we come over on this side, we're going to bend this pin here in to get to VCC, and this pin up here out to get to ground. Like that. And it's kind of held in right now. Just like that. And then we're going to mess me up big time. But anyway, hopefully you can see here. Yeah, pin 7 is ground. Pin 14 is 5 volts. And when we flip it over like this is pin 1. So up here is pin 7. Right up there at the top. And this is pin 14 down here. And so we're folding pin 14 in, because this inner trace here is tied to VCC or 5 volts, and this outer trace, like this outer trace is connected to ground, like that. Alright, and now we're just going to solder this in. I actually tacked in a couple real quick just to make it a little bit easier, but we're just going to solder this. And then this one right here, because we need to make sure that it connects over here to the ground pin, so we need to solder it in, but we also need to connect it to the ground like that. Hopefully you can see that okay. And then this one here needs to be connected to VCC. I don't know what's going on with my soldering right now. All the pins are connected correctly, and so what we need to do now is actually take our drill bit, I'll move this out of the way a little bit. Take our drill bit that comes in there in the toolbox, and look up 7400 again. And drill out connection 3, 6, 8, and 11. 3, 6, 8, and 11. And this is where I get a little crazy. I want to make sure I'm counting correctly. This is pin 1. Yep, this is pin 1 right here. And this is pin 2. And this is pin 3. So we want to drill out pin 3. So we take this and we go 1, 2, 3. And just drill it out with our hand. And we can verify this, hopefully. I'll do it this way. That's pin 1, 2, and you can see we don't have connectivity to 3 because we drilled it out. So the data line, the output number 3 is disconnected from this bottom side. Alright, and we got to do the same thing for pin 6, 8, and 11. 6, 8, and 11. So I'll do that off camera and then come right back. Alright, when I was filming I realized my hands were in the way trying to show this, but after you solder the socket in, if I can get my hands out of the way now, you want to come back and test this. So pin 1 is here, 2, 3, 4, 5, 6, 7, and then if this is only a 14 pin IC or socket, the next pin would be empty. You wouldn't have anything on these two, but this is 16 pins, so that's 8, and then 9, 10, 11, and so forth. The thing is the top side of this is allowing all the signals from the board to come up through the IC, and you drill out the parts on the bottom so that the data lines don't go back from the output from here, go back to the board. That's my understanding anyway. So everything on the top side should have connectivity in your this should be ground and this should be VCC, which are the two outside ones as an example. So I think these two allow for the comparator itself, the outside ones allow for the comparator itself to get power and ground from the board under test. That's why you're folding those pins out, so that not only is pin 14 from the IC connected, but also it's connected to the VCC to the comparator. All right, so it's all finished up. Now we're ready to put a chip in. This is the top side. I put a label on it. The notch faces this way. It has a little label saying what pin 1 is. And then on this side here, some people like to actually cut, let's see if you can see this. Get a close-up right here. Some people like to just cut the traces, I think, up here instead of drilling out the holes. I just, either one is fine. You can cut the traces that go to the pad, or you can actually just drill out the hole, but I'm just doing it exactly how they tell you to do it there. And I've re-verified, connectivity and everything, and that's what it looks like. So it's pretty simple to set up, and then you put your correct chip in there, and I would recommend putting a socket in all of them. That way, if you think your reference chip is bad, you can always test it, like in a TL866 or something like that. But then you put it in here, and there's enough clearance, easily enough clearance for the socket and the chip in there. So that's what I'm going to do. I'm going to actually do a couple more for these chips right here, and then we'll come back and actually put it on a board and test some of them. Alright, so I was setting up, I figured I'd film it from a different angle to kind of show you, make sure I got it on camera good. Anyway, the 74-157, which you should be able to see here, I'll zoom in a little bit. You can see that you gotta look up, you know, either on the data sheet or something like that, but you want to see that pin 4 is an out, pin 7 is an out, pin 9, and pin 12. So those are the ones that we're going to disconnect. Pin 4, 7, 9, and 12. And since this one's a 16 pin connector, when you flip it around, some of them are labeled and some of them aren't. Like you can see this one here, I don't actually have it labeled. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, because we're using all 16 here. The other thing it says to do, which I probably didn't do a great job, you don't want to put too much solder on here because you want to trim these legs as close to the bottom as you possibly can. And that's what I did here. So anyway, we're just going to count from right here. This is 1, 2, 3, 4, and pin 4, if I'm not mistaken. I always get nervous. Yeah, pin 4 is the first out. So we go 1, 2, 3, 4, 1, 2, 3, 4 right here, and then just take our drill bit and drill it out, which is hard for me to do while I'm looking through the viewfinder. There we go. And that should be enough. If we just do a quick check. Right there. 1, 2, 3, 4. No. But right there we have a good continuity. But then on the pad, 1, 2, 3, 4, no continuity. But to the hole we do. So it's disconnected. So that's how you do it real quick. And then I have to double check because I always lose my train of thought. Pin 4 and 7. And then we just keep counting. That's 4, 5, 6, 7 right there. And I'll do that off camera. Alright, so the reason why I started doing this anyway is here's my mishook command. I have a different video I'm working on troubleshooting this thing. But you can see it's really whacked out. And if I put it in test mode, it looks kind of whacked out, but it says ROM okay, RAM okay, something, coin 1 play, and then down here it says bad something, and I figured out it's saying bad map. But I'm not going to go into that too much. I just wanted to cover really why I wanted to use because I'm stumped basically, and I don't know exactly where to go from here, so I figured I'd actually put some test cards in here, one being this 7442, which is a binary something count something decoder or something, I don't know. I'd have to look it up. But I figured what we do is I put this on the tripod, and there's a couple, like N2 is a 7442, and I think there's another one, and we'll check that real quick now that I actually have this working. And we have a couple of these cards made up. I have like a 7157, maybe we can check some chips with a 7400 or 08, and I will put this on the tripod. It's difficult working around the camera here, but I think I showed this before. You just put it in, and the chip is in the right way. It's facing this way. This is pin number 1 over here. It actually tells you that, if you can see it. Pin number 1, slide that in, take our connector that says pin 1 and put that on the chip, which is going to be, get some light on here hopefully a little bit. And now when our chip is on there, we're just making sure that there's no, if any of these lights light up, it means that something's not right. But we can let it run for a little bit, put it back in test mode if we want to, just to see if different instructions are working the chip slightly differently. And no change at all. So that's basically how you test it. And then I was just going through, I'm just going to test some of the TTLs that I think might be as part of the bitmap circuit, or this one's part of the address decoding circuit. But then I'm going to just test some, like I tested a couple of 7404s over here earlier. I can highlight that 7442 and mark it off the list, I guess, as, you know, it doesn't mean 100% that it's working, but it's behaving as expected, or at least the outputs from that chip are the same as a good chip would be based off of the input that it's receiving. The one thing is I don't know are all the inputs actually working correctly. It's just telling you the outputs, right, are what it would match what this comparative chip is. So this is not a foolproof method, but I'm hoping that this might give me a clue of where to look or start digging, find something. Alright, so I found one that was interesting. Here you can see that line number 2 there is on, so it's showing you that that's different than what the chip that's in here, the comparator, is different than the one on the board. So what I did is looked at what that chip was, and it is, well, actually I knew what it was beforehand. Let me take that off real quick. It's a 74H04. So the chip that's in here is actually a 5404, which is like a military grade 7404, but it is a standard, you know, propagation delay of 10 nanoseconds. So I don't know if the difference we're getting is because the chip isn't working correctly, or maybe the difference in the propagation delay between the chip in the comparator and the one on the board. Just real quick, I just took some notes off Wikipedia. So a normal TTL chip like a 7404 is going to be 10 nanoseconds. An L, so a 74L04 would be 30 nanoseconds, so it's slower but less power. Then you have a high-speed one is 6 nanoseconds. So it's definitely faster gate propagation delay than the normal. So I can try, you know, a different chip. An S version is a Schottky is all the way down to 3 nanoseconds, according to Wikipedia anyway. And then your typical LS chips kind of replaced most of these, and that's at 9.5 nanoseconds. And then you have the F and AS variants, which is Fairchild and Texas Instruments, which it doesn't say what the nanosecond delay is, but it's basically the equivalent to the LS. I happen to have a Fairchild 7404. I wrote over it because Fairchild has some wacky numbering schemes, but this is a 7404. I verified that in my TL866. So what I'm going to do is put this Fairchild chip into this reference card that is has the same outputs disabled as a 7404, 05, 06, 07. All the outputs are like 2, 4, 6, 8, 10, and 12, I think. So I can put that in there and see if we get a different result. And if not, maybe I'll try to find an S version. I don't think I have a 74S04, but that could be something that's wrong or bad. Alright, I put it into my ZIF socket, that Fairchild one, and let's connect it up here. Where was I at? This is it right here. Yeah, B6. Is that right? Yeah, B6. That's showing even worse. I don't know what's going on there. Alright, so I've been messing around a little bit and checking stuff, and I saw that, let's see here, there was a bunch of 153s on this board. There's some LS 153s as well as regular 153s. And so I figured what I would do is pull a chip and use this universal card, I guess. I forget what it's called. But anyway, there's a couple benefits of this card here. First off, I pulled this is a 74S153, so it is Shocky and should be pretty fast anyway, but I don't know if that's going to give us different readings or not. And the other thing you want to do is to use this is, I don't know if you can see it, but it says clip here. You can use this universal card as an IC clip and report the status of, I'll show that, report the status of the logic on the chip. And you can also use it as a comparator. So you want to flip that switch that way. All the dip switches, you want them closed for all the inputs, or basically any line that's not an output. And then for the output lines, you move them away from the IC. So in this one, since it's a LS253, you want to move pin 7 and pin 9 out. Those are the only two outputs. And then once you have that done, you just put it in here. Put it in, if I can get it in there. There you go. And then lock down the ZIF socket like that. And then we can just test them real quick. Can you see that? Not really. But should be pretty easy to test. There's like a whole bunch of them in a row. And you can see that it's testing good. I'll leave it just like that. And we can just go, there's 4 in a row. And I have my board running. As you can see there, it's still jacked up. But I'm just hunting and pecking and kind of messing around and sharing. Since I'm using this for the first time myself, I figure I'd share. But there's a 3, and then there's 4, and all of those are good. I have no idea what part of the circuit they are in right now, but I just quickly, you can verify that these are likely good anyway. You don't know. The outputs are definitely looking good based off of whatever the inputs are. And let's see, we have some LS 153s at F5 right here. That looks good. I was getting some weird readings on this before. I was getting some weird readings on these LS ones before, but I guess it's all good now. Maybe it wasn't making great contact. There we see. Now that one, something's, and those are inputs though. 4 is an input, so I don't know what's going on there. You gotta make sure it's making good contact. 74, 153. There we go. We still have pin number 4 acting weird. So I'll make a note of that, and I don't know if it means the chip is bad or not, because that's actually an input, but it's just something I'm going to make a note of and then look at the schematics and see. Yeah, see, now I'm getting some wonkiness here. It's a different chip. And I don't know if it's the chip or if it's because this is a Schottky versus a regular. This one's, but all of these in this line right here of these LS153. So maybe it's giving me a clue that I can look into, but I figured I'd share how that works. Okay, let's do one more thing here. We'll move it to clip, take the IC out. I'm doing it for the first time here. I think you want to open all of these. Yeah, you want to have all of these, I think, in the open position. Hopefully I'm saying it right. And then you want to move this to the clip functionality. And then the lights on here, will just give you a readout of whatever the chip is doing. It doesn't matter what kind of chip it is. It'll just give you a logic level. So instead of using like a logic probe, you could actually check the logic levels of every single pin on the chip with just the clip here, which is kind of cool. So let's just hook on to this bad boy. So pin 8 is ground, pin 16 is VCC, and then basically we have high on some, and pin 1 and pin 15 are stuck low. Now maybe they're supposed to be low, I don't know, but this is a good way to see like the logic levels of the entire chip. What the heck do they call this? Yeah, it's just called a logic clip. Like they make specific logic clips, HP and I think some others, where you'll have a logic clip like this and then a whole bunch of little lights on top of it. This is doing the same thing except for just using the comparator and the lights in the comparator as a logic clip, but you have to have the adapter card. What is this adapter card called? Programmable socket card is what it's called. This is a programmable socket card, and you can it can function as a logic IC. So like let me go to this bad boy here. So yeah, in this version, it doesn't matter. Now, you can also switch the behavior, so all the highs will have the lights off by hitting this switch here, changing it from clip to comparator. It switches the results. So your lows are now lit, and all your highs should not be lit. Which is kind of weird. So these three right here must be in some weird kind of state right there. Probably toggling or something. I don't know if I'm going to use this functionality that much. I like using my scope, but anyway, it's kind of cool. I think that's all I'm going to show for this video. So anyway, screwing around with the logic comparator, showing you some of the stuff, how you can program stuff, and hopefully my hunting and pecking will result in something. I'll link to the missile command video if I find something. Alright, thanks for watching, guys. Till next time, see you later.